When we eat food, the essential vitamins and minerals are processed in our bodies. Different elements make up the food that we eat. These elements, as we all know from our previous science classes, are made up of atoms, which are then composed of three subatomic particles: the protons, the neutrons, and the electrons. The interaction between these particles explains a lot of phenomena that takes place in our everyday life. In this module, we will begin our study of electromagnetism by examining the nature of electric charge and how they are transferred from one material to another. You probably have done this simple activity before. You rub two inflated balloons to your hair. Then, you bring them together and you would see that they are moving away from each other. This happens, you probably know, because we move by rubbing the electrons from one material to another. As we rub, the balloons gain electrons while your hair loses them. But we will have an in-depth discussion of this later. You see, this interaction of charges is crucial to understand electricity and magnetism. This charge or electric charge is the fundamental property of matter that is carried by elementary particles found in a single atom. The idea that all matter has this fundamental property was discovered by Benjamin Franklin, an American physicist, who carried out a series of experiments involving flying kites during thunderstorms. He was the first to use the notations positive and negative to describe charges, which are still adopted until today. In 1897, J.J. Thomson discovered the presence of the electrons. Through a series of experiments, he found that all electrons present in every atom have the same charge. This was supported by Ernest Rutherford when he shows that atoms contain protons that have an opposite charge of an electron. Since the negative charge is assigned to the electrons, while the positive charge is assigned to the protons, we only have two types of charges, and the materials can acquire these charges depending on the number of protons and electrons present in them. We also use coulombs or C as the unit of charge. Let us try again to remember the concepts physics tells us. I have here two sets of charges. Each circle represents the charge. What do we remember about the behavior of these charges towards one another? That is correct. Experiment tells us that the negatively charged objects are attracted to the positively charged objects, but they are repelled by any other negatively charged objects. That much we know already. But what we are interested to know is how those with a static charge or neutral charge. Can there still be an attractive force between a neutral object and a charged object? Correct, that is still possible. An attraction between charged and uncharged objects is still possible through charge separation in the uncharged object. It means that the electrons in the neutral sphere are attracted to the positive sphere and moves towards it. The electrons are already closer to the positive charges in sphere A than the fixed positive charge on B. Hence, the overall force is towards sphere A as the force between two charges increases, with a decrease in distance that separates them. Before we go any more complex in our first lesson, let us review that there are two types of materials based on the ability of the object to let electrons move through it. Conductors are materials that permit electric charge to move easily from one region of the material to another. On the other hand, the materials that do not let this happen are called insulators. Based on this short description and on your own experiences, can you identify all insulating materials? Very good. In the next lecture, we will talk about methods of charging. Also, I hope you noticed that I already introduced you with one of the most important laws of electromagnetism, which is the Coulomb's law. Can you remember in which part of the lecture was that? I am sure you are as excited as me. But that's all for this lecture. I am Gilmar De Castro, and see you in the next video.